As I mentioned before, these double angle formulas can be used to help us solve trigonometric equations. In this case, we are asked to find all the solutions of the equation in the interval 0 to 2 pi. And our equation is sine 2x minus the sine of x is equal to 0. Now, earlier on in the chapter, we actually solved a few multiple angle equations. And those trig equations, the trig function only had a 2x. And notice that inside of this trig function, I've got a 2x, and inside of my second trig function, I have an x. Because these are different, we are going to have to use a double angle formula. If both of these had a 2x, then we could use a u substitution to help us solve. But because we have different quantities inside of the trig function, we can use a double angle formula here to rewrite the sign of 2x so that all of our trig functions just have x's inside of them. Well, what's the double angle formula for sine 2x? Sine of 2u is equal to 2 sine u cosine u, which means that the sine of 2x can be replaced with 2 sine x cosine x. So I now have 2 sine x cosine x minus sine x is equal to 0. And that helps us again because now each trig function just has an x inside of it. Well, what do you notice between these two terms? Each one shares a sign. And whenever you're solving trig equations, you always want to have factoring in the back of your mind. Look for opportunities to factor. And in this case, we can factor out a greatest common factor of sine x. Factoring out sine of x, we get sine of x times 2 cosine x minus 1 is equal to 0. And we can set each one of those factors equal to 0 and isolate the trig function. That gives us sine x is equal to 0, and cosine of x is equal to 1/2. Now that we have our trig functions isolated, we can go to the unit circle and find our solutions to the equation. Now notice this problem is asking for solutions on the interval 0 to 2 pi. So we don't have to tack anything onto our answers. We're just looking for the answers that are in our unit circle here. Well, which angles have a sine of 0? Well, sine corresponds to the y-coordinate, so angles that have a y-coordinate of 0, that is going to be 0 and pi. Notice that 2 pi also has a y-coordinate of 0, but it is not included on the interval that we are looking at. Then we can identify the angles that have a cosine value of 1/2. Well, cosine corresponds to the x-coordinate, which angles have an x-coordinate of 1/2, pi over 3, and 5 pi over 3. So those are our solutions. X is equal to 0, pi, pi over 3, and 5 pi over 3. Let's try another one. Solve the following trigonometric equation. Here, 4 times the sine of x times the cosine of x is equal to 1. What can we do in this case? Well, this is in the double angle formula section of the chapter. So what double angle formula does this almost look like? This almost looks like our double angle formula for sine. However, instead of a 2 in front, we have a 4 in front. But hopefully you agree that 2 times 2 sine x cosine x is the same thing as 4 sine x times cosine x. So we can begin by just factoring out a 2. 2 times 2 sine x cosine x is equal to 1. Now I can use our double angle formula. 2 sine u cosine u is equal to the sine of 2u. So what can I replace 2 sine x cosine x with? I can replace that with a sine 2x. 2 sine 2x is equal to 1. And now we can begin to isolate our trig function. We divide both sides of the equation by 2, and this gives us sine 2x is equal to 1/2. Now, this is a multiple angle equation. However, there is only one trig function, and it has a 2x inside of it. So to solve this in the most simple way possible, we can actually use a u substitution like we did before. Let u equal 2x. I can now substitute u in for 2x. That gives me the sine of u is equal to 1/2. From here, I can now go to my unit circle and identify the solutions. Now, this one just says solve the trig equation. We're not looking for the solutions on the interval 0 to 2 pi, but we need to account for every single angle that has a sine value of 1/2. Well, we can do so by starting with our unit circle angles. All right, sine corresponds to the y coordinate, so we want a y coordinate of 1/2. That's pi over 6 and 5 pi over 6. Well, to accommodate for every single angle that terminates in the same location as pi over 6, we can tack on an n2 pi. We get u is equal to pi over 6 plus n2 pi. And to account for every single angle that terminates in the same location as 5 pi over 6, we can tack on an n2 pi as well. Notice that these are my solutions for u. Our goal, however, is to solve for x. So what do we need to do now? Replace u with 2x. We know that u is equal to 2x. So we replace u with 2x, and to solve for x, we divide everything we see by 2. Remember, dividing by 2 is the same as multiplying by 1/2. That gives us x is equal to pi over 12 plus n pi, and x is equal to 5 pi over 12 plus n pi. All right, so there are a couple different ways that we can use these double angle formulas to solve trigonometric equations. Coming up next, the half angle formulas.